let's now take a look at using the law of sines to solve oblique triangles that are case 1 type triangles. Case 1, when we're given 2 angles and 1 side. So our objective, use the law of sines to solve an oblique triangle when given 2 angles and 1 side. And these are sometimes written in shortcut angle, angle, side, or angle, side, angle. All right, as usual, let's go over the list of things we know, if there's anything that's going to be relevant to this video lecture. Well, from the previous video lecture, we know the law of sines. The side of A divided by the sine of the opposite angle is equal to the side B divided by the sine of the opposite angle is equal to side C divided by the sine of the opposite angles. So what we have here are 3 proportions. There's a proportion, there's a proportion, there's a proportion. Okay? Number 2, we know what solving a triangle means. We find the other 3 parts of a triangle when given 3 parts, at least one of which is a side. Number 3, we know the sum of the 3 angles in every triangle is 180 degrees. Number 4, we know that side lengths and opposite angles of triangles are directly related. The largest angle of a triangle must be opposite the longest side, and the smallest angle must be opposite the shortest side. And finally, let's go back to that proportional knowledge we know. When 2 fractions are equal, they form a proportion. Again, if I put my finger over this one, I have 2 fractions that are equal. They form a proportion. The cross products of every proportion are equal. And that's how proportions are used to solve problems, because we can do their cross products and solve for a single unknown. Okay, let's take a look at, I think I've got 3 examples here of 2 angles and 1 side. Here's the first one, straight up, not a word problem. So we'll just take a look at it here. Solve the triangle below. Okay, well, I think what I first want to do, let me find my notes here, make sure I got my notes. There we go. I'm on the wrong page. Sorry about that. Okay, let's first label this triangle. I'm going to label this triangle angle A, angle B, and angle C. I'm going to label it like that. If that's angle A, then this is side A, so the length of side A is 7 units. If this is angle B, then this is side B. If this is angle C, then this is side C. Okay, so we know. Okay, we know that angle A is 35 degrees. We know that angle B is 105 degrees. And we know that side A, little a is a side, is equal to 7 units. So, to solve, we need to find the other 3. So we need to find angles, whoops, I did that in my notes, I didn't want to do it here. We need to find angle C, we need to find side B, and we need to find side C. To solve the triangle, we need to find all 6 parts. Well, by far the easiest thing to start with when you're given 2 angles is you can find the 3rd angle, because the sum of the 3 angles in every triangle is 180 degrees, and that's number 3 right up here. Okay, so angle C is equal to 180 degrees minus 35 degrees minus 105 degrees. Angle C is equal to 40 degrees. By far the easiest thing to do when you're given 2 angles is to find the 3rd angle. Just subtract the 2 angles from 180 and we're done. Okay, now let's find side B. So we're going to find B. Okay, so the relationship we know, remember these are our relationships right up here. A over sine A, B over sine B, C over sine C. Well, we know the A relationship. We have that full ratio. We have side A, we have angle A. So let's use that. A over the sine of A. We know those two. Okay, and we're looking for side B, so we're going to use angle B. So we're looking for side B, and we know angle B. Okay, so again, back to our proportional reasoning. Okay, we can solve for any proportion if we have one unknown. Well, we know this, and we know this. We can find this with cross products. Length of A is 7. Sine of A is 35 degrees. Length of B is our unknown. Angle B is 105 degrees, so sine of 105. We just formed a proportion, so their cross products are equal, and I usually put an X in there to indicate that I am doing cross products. So I know that B times the sine of 35 degrees is equal to 7 times the sine of 105 degrees. Now, I don't pull my calculator out yet. I'm going to solve for B. I'll divide both sides by the sine of 35. And of course, that's a big old 1. So I have on the left B equals. I'll divide this side by the sine of 35 degrees. Now I'm ready to do the full calculation. I'll put this into my calculator. And I came out with 11.8 rounded to the 10th. 11.8. So B is equal to 11.8 units. Let's do a quick check here. The length opposite the 35-degree angle is 7. Well, the angle for B is 105. Since 105 is larger than 35, then the side opposite B better be larger than 7, and indeed it is. It's almost 12. Okay, again, the side opposite the largest angle better be the longest, and the side opposite the smallest angle better be the shortest. Now let's find C, and again, what we were given was a relationship between, this was the one we were given. We knew side A and angle A. So let's keep with that. Let's continue to use what we're given because we know those are correct. And now we're going to find C, length C. So our proportion is side A over the sine of angle A equals side C over the sine of angle C. Let's substitute. We know this first ratio is 7 over the sine of 35 degrees. And the second ratio, we don't know C, but we do know angle C, so it's C over the sine of 40 degrees. Okay, again, I have formed a proportion. Two fractions that are equivalent form a proportion. Cross products. Okay, so C sine 35 equals 7 sine of 40. And we'll do the math to all that. I'm not going to rewrite all this. We come up with C is equal to 7.8 to the 10th. Over here, C is equal to 7.8. Okay, again, it's nice to check it. All right, because this is the smallest angle. This should be the shortest side, and that's correct. 7 is shorter than both 7.8 and 11.8. Because this is the largest angle, this should be the longest side, and that is correct. 11.8 is greater than these two. So it's important to kind of check to make sure that you got everything correct. Okay, let's do a couple of real-life cases, real-life examples. Okay, draw these out and take a look. Let me get my paper where it needs to be, I think. Get my notes together. Okay, I think I'm going to do a little bit of it, just if I can't straighten that out. Okay, I got a couple of examples here. Example 2. Two observers, A and B, sight a helicopter above them to the right. The observers are on flat ground 3,540 feet apart, and the angles of elevation, we need to know what that means. They each measure to the helicopter are 32 degrees and 44 degrees respectively. How far is observer A from the helicopter? Okay, let's do it. Let's get flat ground. Let's get A, observer A, and observer B. Okay, the distance between these two is 40 feet. Helicopter, let's see how I do my drawing here. A big, go like that, we'll go like this, a little fan, we'll go up here, we'll get a big blade, and a small, there we go, there's my helicopter, nothing fancy. Let's see here, they're a flat ground, they're looking up. So A looks up to here, and B looks up to here. Angle A, the elevation, of course, angle of elevation goes from ground up. So A is saying 32 degrees, B is 44 degrees, and that's what we have. Okay, so there's our picture. Picture, very important, really makes a difference when you're trying to solve a problem. Get a good picture. Now let's label this thing. Let's see, I'm going to call this C. So that's angle C where the helicopter is. So I have my ABC or whatever, but that works. Which means this is little c. Okay. Which means this is little a and this is little b. Whoa, hang on a second here. I don't know angle B. I mean, I'm looking for a triangle. Okay, so again, let's make a note of that. Look for and label a triangle. That's important. Well, my triangle is here to here to here. This angle is not inside the triangle. Okay, I'll make a note here. Need to find B. Well, I know that angle B, that B inside the triangle, because I'm looking to, I need to have what's inside a triangle. B inside the triangle is equal to 180 minus 44. Okay, so that's 136 degrees. So that's nice to know. This is 136 degrees. Okay, so there's my triangle. Now I need to find this. So I know I need to have the ratio B over sine B because I'm looking for B. I don't know A. I don't know how to find that, but wait, I can find C, angle C. Well, angle C is pretty simple. Okay, again, we can always find, when we're given two angles, we can always find the third angle using subtraction. Okay, so 180 minus 32 minus 136. Angle C is 12 degrees. Okay, well, there we go. Now I have a known ratio, length of C over sine of C, and my unknown ratio, length of B over sine of B. So the known is going to be C over the sine of C, and my unknown is going to be B over the sine of B. Well, C is 3540 over, the angle is 12, so over sine of 12 degrees. B is the unknown, and the angle is the sine of 136 degrees. That's what I'm looking for. What's my ratio? There's the ratio. Cross multiply and divide. I'll let you do all that. And it comes out that the length of B is approximately 11,526.9 feet. So normally, once I've done this, once I put an X in here, I'm telling whomever looks at this that I use cross products. I cross multiplied and divided like I learned in middle school, and that's what popped out. Okay, one more example. Give me a second here to get my my phone is playing with me a little bit, so give me a second to get it back together. Okay, one more example. Example 3. Whoops, looks like I've got myself a little bit. Okay, example 3. My book's on the way over here. All right, I think I got it. All right. The loading ramp at a delivery service is 12.5 feet long and it makes an 18-degree angle with the horizontal. If it is replaced with a ramp that is 22.5 feet long, so we're going to do a longer ramp, which is going to make it easier to get up, okay, to the loading ramp. What angle does the new ramp make with the horizontal? Okay, let's see here. So here is the delivery service. I'll go like this. Okay, I need to get up to there. Here's the old ramp. This old ramp is 12.5 feet long and it is an 18-degree angle, and that's somewhat steep perhaps. They want to make it less steep. So we want to come up with a new ramp. Whoops, that's not the best straight line. That's pretty pathetic actually. So let's try it again. Okay, we want a new ramp that's going to be 22.5 feet long. And the question is, what is this angle here? How many degrees is that? Now, obviously, we want to recognize something. The longer ramp is going to have a smaller angle. That makes sense. Okay, if you're going to have a longer ramp to get to the same height, you're going to wind up with it being less steep. The shorter the ramp, of course, the steeper the angle will be. Okay, find your triangle. Well, this is my triangle. I'll label this A, B, and C. My triangle is right here. Okay. Now let's look at what we're looking. Let's label it with our A's, B's, and C's or whatever. First off, notice that 18 degrees is not inside of here. Okay. So we know we're dealing with triangle ABC. And we know that angle B inside of this triangle ABC is 180 minus 18. It's a 162-degree angle. Okay, so now I have a known relationship. This is in this triangle right here. I'm going to hide this piece. So in this kind of long, narrow triangle, I know B and angle B. I'm looking for angle A, and I happen to know the side opposite angle A is 12.5 feet. So I don't even need to worry about finding angle C. Angle C doesn't do anything for me, so I'm in a good place. So the one I know is B over sine of B. Okay, the one I'm looking for is A over the sine of A. Okay, so the length of B is 22.5. The angle is 162, so that will go over 162, the sine of 162, excuse me. The length of A is 12.5 feet, and we're going to put that over the sine of angle A, which is what we're looking for. Okay, again, cross products. Okay, I'll do a bit more math with this one. This is going to be 12.5 times the sine of 162 equals 22.5 times the sine of A. Okay, if I divide both sides by 22.5, the sine of A is equal to 12.5 times the sine of 162 divided by 22.5. Well, I don't need the sine of A, I need to find A. So A is equal to the inverse sine of all that stuff. 12.5 sine of 162 divided by 22.5. Whew, that's a lot. Now I'll pull my calculator out and put that in just as written. And it turns out that angle A is going to equal approximately 9.9 degrees when I round to the 10th. And again, does that make sense? Well, we knew that it was going to be less than 18 because we had a longer piece here. This is the largest angle, so this this is the longest side. This is 12.5, so this better be less than 162, and it obviously is. So there you have it. A lot of work with this, with the law of sines in case 1. In our next video lecture, we'll take a look at case 2.